Okay, let's now look at equations involving absolute value. And remember, absolute value of A is the distance A is from 0 on the number line. And we saw that that means that the absolute value of A is one of two things. It's either A itself, if A is greater than or equal to 0, or it's the opposite of A if A starts out being negative. Okay? So when we're solving an equation with absolute value, remember we always want to eliminate the absolute value bars. And so what we see is the absolute value of A has two ways for that to happen. It's either equal to minus A or A. So when I'm solving an absolute value equation, I'm going to be solving two equations. If I want to say the absolute value of x equals A, that can mean either x equals A itself or x equals the opposite of A. And so you have to solve two equations, okay? But notice too that if the absolute value of x equals A is greater than or equal to 0. And so we only can solve equations where that right-hand side is either 0 or positive. So watch for that as you're solving equations, and look for those tricky, quote, tricky questions where they might have it equal to a negative number. For example, look at this first equation. What's the first step? Is to isolate the square root. Isolate the absolute value. And we get that absolute value of 3 minus x equals 2 minus 4 equals negative 2. And if I'm smart, and if I look at it correctly, I see, wait a minute, that's just like the equation we began with in this very first slide of the lecture. That equation has no solution, because an absolute value can't equal a negative number. So I don't have to go any further. Okay? So watch for that. But in most cases, we're not going to try and trip you up all the time. So we're going to actually want to solve legitimate equations. So here is an example, and I want to solve that equation. So I have two equations that I have to look at. First of all, what's in the absolute value bar equals x itself, or what's in the absolute value bar is equal to the opposite of x. There are two options, either x equals the number or the right-hand side, or its opposite. All right, so then we just solve them like any, in this case, any quadratic equation. X squared minus x minus 6 equals 0, and this one happens to factor. So I see that x equals 3 or x equals negative 2. Okay? The second, I get x squared plus x minus 6 equals 0. That factors as x plus 3, x minus 2. So it looks like x equals negative 3 or x equals 2. Great. Everything is good, but I have to worry about that quantity being positive or negative. In other words, is the equation well defined if I substitute? So bottom line is that I need to check each of those solutions. Okay, where do I check them? In the original equation. So let's start with x equals 3. Remember, I have 4 choices now. 2 from the first equation, 2 from the second. So x equals 3, I plug that in. 3 squared minus 6 is the absolute value of 3, which is equal to 3. So that one works. Second, x equals negative 2. The absolute value of negative 2 squared minus 6 is equal to the absolute value of 4 minus 6, which is equal to the absolute value of -2, but the absolute value of -2 is +2. It does not equal the -2 that I need, because remember the right-hand side has to be -2. So this one, no. Okay, so x can't equal -2. And you will see very easily that I have the same problem if I try plugging in -3, because that's going to be a positive quantity and I'm asking it to be equal to -3. And the answer is no. Okay, now does that mean every negative value is going to fail in any equation? Absolutely not. You have to test each one to make sure. But we do still have one left to go. X being +2, I get 2 squared minus 6. And the question is that equal to just 2 itself? Okay, remember I'm going back to this equation to solve. And sure enough, I get 4 minus 6 is the absolute value of -2, but we know that that's 2, so it works. So what are my solutions, the legitimate ones? X equals 3 or x equals 2. Now please don't shortcut this process and try and come up with tricks so that you know when it works and when it doesn't, because every equation is different. What you have to remember is when you need to check. And it's a good idea to check all the time, but you have to check when you have rational expressions, radicals, rational exponents, or absolute values. Okay? So don't miss a problem on a quiz or a test because you don't check your solutions. Thank you.